Hi, my name is Murray Walker. I lead Zutari's interactive visualization team out of Cape Town. If any of you are unaware of or haven't heard of Zutari before, you may be familiar with the engineering consultancy Oricon. The African business split from Oricon last year and rebranded as Zutari in July. We are now a company fully focused on offering engineering services on the continent. So I thought I would start by speaking briefly about what interactive visualization is and what it is not. The term is kind of vague, so let's break it down. The way that we think about it is that interactive visualization offers a door into new ways of approaching engineering design. It does not replace the usual ways of designing. Unless you're still designing in 2D, then it most definitely disrupts your way of work. But if you are already designing in 3D, using Revit or Rhino or most other 3D design packages, then interactive visualization is a supercharger to your workflow, and we'll see why a little later in this talk. Interactive visualization is the use primarily of a game engine to build custom tools that are used in design review and in client and stakeholder engagement. Typically, a 3D model from your engineering design package is exported to the game engine, and from there tools are developed and used to make exploring the model and interrogating the design faster, more immersive, and ultimately more reliable. The outputs from the game engine are typically game-like. You can walk around, click on stuff, take notes, move things around, make fly-throughs, visit your friends in a networked environment, and or even don a virtual reality headset and immerse yourself in the design completely. But why a game engine? Well, we think of it more like an engineering engine. These engines are incredibly sophisticated software. Games are all about world building, and engineering is exactly the same. We build the physical world. At the foundation is the physics. Game engines do a great job of simulating physics, and they're only getting better. This physics simulation is what we use to build all manner of interactions into 3D models. There are two dominant game engines that are available to people in the AEC industry. They are Unity and Unreal Engine. Both, of course, have their roots in gaming, but they noticed some years ago that the use of their technology was becoming more prominent in our industry, and so they have started to build tools specifically for us. Both of them are free to use if you are curious to play around with them, but if you do official projects on either, you will most likely need to purchase a license. That's interactive visualization in broad strokes. Let's take a few minutes to see some examples of this work in our 2020 showreel. You may have noticed that we've also created things like animations and films. And while we can and do create these types of content, I don't define them as interactive visualization. As the name implies, For something to be interactive, you can't be a passive consumer of the content. You must interact. While there is certainly a time and place for films, we believe the interactive component of visualization is really what will add value from design to construction to operation. We believe that interactive visualization should become a central aspect of pretty much every infrastructure project on the continent. We've been exploring how to do this for the last 4 years or so, and we have seen the value for our design teams, and we've seen our clients' eyes wide with wonder when they take a VR headset off after walking around their project for the first time. Engineering is changing and digitizing and being disrupted, and visualization forms a part of this. Indeed, it could become the central pillar of delivering infrastructure projects, and so it should be. So let's look at how we can make interactive visualization that central pillar. Let's look at a basic project lifecycle and see how visualization fits into each step. We start at the concept phase. Africa is big, and there are many projects that take place in expensive to reach places. Using visualization and other tools like reality capture, we can bring those sites into our offices, into our clients' offices, and explore them as if we are there. Everyone on the design team, from the most junior to the most senior, can get a sense of all the dynamics at play and be better informed when they sit down to design. It's important to emphasize how important this is. We all know what it is like trying to make a decision when you don't even know what you don't know. We can largely erase that issue now, and we should. If nothing else, it will save everyone a hell of a lot of money, not just from travel, but from making better and faster design decisions. As we move into the serious work of actually designing something, visualization can lend a hand on a daily basis. Workflows are developing that can rapidly bring a 3D design into a game engine, allowing for engineers and technicians and draftspeople to flow between design and review and decision making. As a visualization team, we can develop custom tooling in the game engine that can smooth and enhance this flow by acting on the rich BIM data in the model, allowing those in the design to catch mistakes earlier, conduct quick analysis, like correct spacing of fire sprinklers, for example, give clearer instructions for revisions, and yep, you guessed it, ultimately save time and money. And then there are obviously many occasions where we have to interact with clients, and here again, visualization can be extremely useful. Where before you had to throw down a pile of drawings on a big boardroom table and poke your finger at lines on a page, now you can hand the client a VR headset, put one on yourself, and explore the design in one-to-one scale, speaking specifics. No more trying to imagine what something on a drawing looks and feels like in 3D reality. Custom client-specific tools can be employed here too, to enrich the engagement and bring even more clarity. The result being clearer understanding, more concise conversations, and less distance between expectations and reality. Similarly, our clients' deserve to better understand how projects will affect them. Social housing recipients can explore their new homes, a neighborhood can see the visual impact of a new road being constructed through their area, and prospective tenants can understand the shop space they're thinking of renting in a new development that hasn't been built yet. Often a big issue with community resistance to a project relates to a lack of understanding of what the various impacts might be, but visualization gives communities a way to either confirm or realize that their fears were unfounded. And then we get to the important construction phase. Before construction starts, contractors need to tender for the work, making available immersive models for them to explore while putting their proposals together will help de-risk things for the contractors, as they can get clearer insight into the intricacies of a project. This would lead to more confidence on contractors' part, and our hope is that with less risk, the prices come down, saving our clients money. Once a contractor has been chosen, for them to have access to the model and have tools that help them sort through the model, like maybe seeing where services can go in a wall, will help speed up installation and reduce the risk of mistakes being made and delays resulting. When multiple contractors are involved, which is often the case, coordination using an interactive model can offer all parties greater clarity, and discussions around tricky aspects of the project can confidently be solved before picking up any real tools on site. And then once construction is completed, the design model can be updated to reflect the as-built condition of the model. This would typically be done via reality capture, and then an extraction from the point cloud of all the components. This is perhaps the least developed part of the process, but it is a crucial step for the next part. The final part of this revolves around what happens when a site is handed over to the client, and they are now responsible for operation and maintenance. With an interactive model of their building, plant, or factory, data from sensors around the facility can be piped into the model, giving the client real-time insights in an intuitive medium to what is happening in their facility. Additionally, immersive training modules can be developed that can help bring new operators up to speed faster, more reliably, and safer than traditional training methods. So I think you can see here, as we get to the end of the project lifecycle, how a 3D model, and in particular an interactive 3D model, has this longevity through a project. It's not just useful to generate drawings with anymore. It can be used in all different ways, and it's just adding value at every stage of the process. But next is a really important part that I'd like to discuss briefly, and that has to do with the point or the reason we're all in this conference, and that has to do with data, specifically BIM data. Central to all of what I've described is the BIM data. This is a conference about data and its importance in the future of our industry, and I just want to echo that importance. In order for interactive visualization to become truly powerful, it needs to have a foundation in consistent, comprehensive, and trustworthy data. Once that foundation is in place, we can build useful tools that act on that data to give us insights into the design or help us link virtual components to their real-world twins once a facility has been constructed. Next, I'll show you a couple of examples of some work, and we'll do a bit of a demo, and just to hopefully give you some real sense of some of the work that we've done, but also some practical examples of what I've been talking about here. So here we are in the Unity game engine, and I wanted to show you how we're importing some data from a design. Typically, this is a solar farm, and so they are still designed in 2D in AutoCAD, although that's changing. But we are taking that design data and building 3D models out of it pretty rapidly these days. So I just wanted to show you that. If we take a look around here quickly, you can see there's a little solar farm as an example and a bit of a wind farm in the distance here. And this is what we call Playground. It's a place for us to show generic projects with custom functionality that we have been building. And our plan is to roll this stuff out to the different units. In this case, it's obviously related to renewables. So let me show you this quickly. As you can see here, I already have the piles in the ground, and I have some inverters in the distance there. And what I'll show you is how we can quickly just spawn the trackers. And so if I come here and I do this, just place the objects, the trackers appear, and they are taking the terrain into consideration, their rotations, positions, all that is coming in. And then without too much further effort, we can just set a couple things up, and there's this additional functionality that we can then use to make some design decisions. So what I was doing there is just making them available for the sun to take them into account, and here I'm just refreshing this so they reference the information on each table as you can see here, there's data on the table about rotation and when and it should be turned on and off in relation to its construction date. This is the build of what you saw in the editor just now, and now you can see the functionality at work on the design. So we can quickly check what the shading is going to be like. Obviously this is important when it comes to solar farms, and so we can quickly see, oh no, this shades tables too early in the day, we definitely need to space them a little bit further apart. You can see here too that you can see each month of the year and then get details about that. The sun is positioned according to this real world location, and so the sun stuff is pretty accurate. And then the other thing is the construction sequence. We can quickly get a sense for when things are going to happen in this construction process, and this is really, really useful to all parties involved. And then there's something else that's unrelated to solar farms, but is about renewables. You can see in the distance here there's a blade truck, and we put this together to test the road designs on wind farms. They have a lot of restrictions because of the length of these trucks, and so we thought we would try and simulate driving through a site and testing these roads, see that the corners aren't too sharp and the rises aren't too steep, etc. All of these things are factors when it comes to designing the roads that deliver the components of the wind turbine. So let's take a look at this quickly. Here's the truck. You can see it's really long, and so you can jump inside it and you can drive it. So apologies for the flashing in the distance here, but you can also see at the back here we have a view of the trailer, and this is because the trailer's steering is independent to the horse on the front. And so as we go around this corner, we can manipulate the back of it to make sure that it can get around the corner. I'm pretty bad at this, but there are others in the office that are better at it than me. And so this would obviously not be possible on a normal truck, but this is where the power of a game engine comes in. It's built to simulate things like this. You can get to a relatively accurate level of detail in terms of the physics and the scale and whatnot, and so this becomes really, really useful. I'm going to sort of run to the end of the road here, but I think you get the idea here, which is really, really cool. And this has been highly useful to our design teams, who sometimes don't get a sense of what the site is really like, or they've never really designed for a wind farm before, and so this helps to give them insight into what they need to do. Next up is a bit of a workflow demonstration. Tools exist now that make the transfer of data between your design software and the game engine really easy, and there are trade-offs to this, but for the most part it is making life a lot easier. And so what you see here is Revit, and this is just one of those basic sample projects that Revit supplies. And what I've done is set this up, and it is now syncing, and so you can take a look at it on the Unity side. As you can see here, we have the site. You can recognize it, and this is brought in pretty easily. But what I wanted to talk about first is some of the tooling that we've built around this. So what we can do here is you can see that this is a really it just has all the components, thousands of them, just in a bit of a mess here. So in order to make this a little bit more workable, we built a quick little tool that that can help sort this stuff out, and so and it's really easy to do. I'll show you how now. So just by taking that in, I can run this, and you'll see now that everything is neatly in its family, which makes life a little bit easier. But what you can do is, so this is one way where you're importing the model into the editor to work on the model itself, but we also can do it in a viewer. So what you can do is, once you have some trustworthy data on the BIM side, which comes in looking like this, you get this metadata component, and all the BIM data that you find in Revit comes across into Unity, and then you can build tools that work on this, right? And build the functionality in, and then you can issue a viewer. So hopefully this viewer will open up quickly, and I'll show you what happens on the viewer side. So you can either publish projects via Revit via the cloud from Revit, or you can do it locally. Obviously, the cloud gives you more flexibility in terms of who you can share your models with, but you can also keep it private and share on your local network, which is quite nice. So I am just opening this project up. You'll see it loading in, but what's actually happening here while it's loading is that we are acting with our custom tooling on the metadata that's being streamed into the scene here, and once it's all loaded in, you will be able to see some functionality relating to that data, and so we can query whether things are designed correctly. You'll see something around the fire sprinklers. Are they placed in the correct positions to maximize reach in the room, for instance? And there are other things here too. So I really think that the limitations on what tools you can create is pretty much infinite. There really is no limitation as long as you have consistent data coming in. And that's what I mentioned earlier about BIM data being the foundation with which you're going to really supercharge interactive visualization. Without that foundation, life is a lot harder. Okay, so it is now spawned in, and I can just run around here and show you what happened. So in this case, as we're prototyping some of this stuff, we've chosen to just use the light switches as the trigger. And so if you click on the light switch, a bunch of things happen in the room, and you can quickly get a visualization for coverage. So the green things are a little bit hidden here, but they are air terminal coverage for the HVAC, and the yellow ones are the minimum coverage of the sprinkler, and the blue ones are the maximum coverage. And so you can quickly see, okay, this room looks pretty solidly covered. And then there's another thing that we did, revolving around the lighting. So if you set up a switch ID, you can link all the lights in a room to their switch, the switch that they belong to, or the sensor that they belong to, and you can quickly check if that data is correct by clicking on the light again, and all the lights go off. So you'll notice there's still an emissive material there. We're working on that, but you'll see here the lights coming back on again. And then let's say you're walking around and you find something that you'd like to change. So this is where it gets really interesting, because now there's a live link between what we're doing in Unity and what we are doing in Revit. So if we go back to Revit quick, and let's just say, okay, we really wanted to move this lightning conductor. So let's move it back over here. It takes a couple of seconds to update, and then if we go back to the Unity project and we click sync on the Unity side, it just takes a couple of seconds. And if you have a better connection than I do, it's normally quicker. And if you're on your local connection, it's also generally quicker. And so you can see that conductor is now popped back into its position. And you can do this for any component in Revit. You can have these really dynamic design review sessions instead of looking at some drawings or looking at something in Revit. You can take a look at, you can walk around it and do all kinds of queries on the data that you have coming in and the tools that you've previously created. And you can take a look and then make adjustments on the fly and see what works and see what doesn't work. So just some other things here. This is some basic functionality that's built in here, but you can also customize this, for instance. So this is also working on some of the BIM data, but we can see these air terminals coverage in the rooms, and so we want to look at where each of those air terminals are, and you can quickly get a sense of what's going on there. And likewise for anything else, you just want to look at the ceilings and so on. And there's also a sun study in here, so this is a bit clumsy, the look and feel of it, but you can change some shading. It's not too effective when everything's switched off, so let's switch everything back on again. And you can see how the light moves and what the light is going to be like at certain times of day in these rooms, which I think is a really useful tool, and again just helps to illustrate what your what the impacts are of your design decisions, and you can go and change them. One other thing is that you could obviously push some of this stuff to mobile. Your mobile phone, for instance, you'll see this here. This allows some augmented reality functionality, which I can't show you now because I'm on my laptop. But if the model is not heavy enough, you can deploy an app to your phone that is, again, a customized app, and you can view these models in AR, which I think is exciting, and it's only going to get better over time. So yes, that is the Unity product. There are also options in Unreal that we don't really use, but I'm not here to talk about Unity and market them. So if you are interested in taking a look at Unreal, they have some really, really powerful tools. Their tool is called Datasmith, and it basically does exactly what this tool does, and is really interesting. It allows for lots of customization, and also has many other inputs. So one of the inputs that this tool has that I'm showing you here is Navisworks. So I showed you just the Revit plugin. They have Navisworks, BIM 360 is coming soon, and I think that's just going to make this stuff even more powerful and accessible, and faster to iterate on, which is really exciting. So that's it for the workflow side of things. Let's take a look at some other stuff that I'd like to talk about, especially around mixed reality and what some of those terms mean and what they can enable, because I think that they play a really big role in interactive visualization. I think what makes interactive visualization really, really exciting is the advent of two new technologies. They are virtual reality and augmented reality. Commonly, you'll hear them referred to as mixed reality. And for anyone who is unfamiliar with the term, it is a catch-all for those two things. And virtual reality is when you don a headset like the one in this picture, and you're fully immersed in a model. And it can be anything. You could be on the beach or in a pump station. And so what VR enables you to do is get a really nice sense of space, just like you do in the real world. You walk into a room, you really immediately can just intuit its size, whether it's pokey or whether it's nice and big. You just get a feel for it, and you get that same feel as you do in real life, you do in VR with that one-to-one scale. It really changes the game when you're doing design review or showing a client the work that you've done. They really do get a much clearer picture than they do if they're looking at drawings or even if they're looking at a Revit file. And then you get into, and then one other thing is that you can interact. So you can walk up to stuff, and using the controllers that are tracked, they become your hands, and you can press buttons and open doors and turn on lights and all kinds of other things. Use pointers and write. There's a microphone, and you can record, and that becomes really useful, and obviously plays a big part in interaction. And then when we move on to augmented reality, I think augmented reality in terms of technological maturity is still a bit behind virtual reality. It's catching up, I'd say, and to be honest, it will surpass virtual reality in terms of its usefulness, I think. But the technology is still being developed. But if anybody listening to this has experienced augmented reality on their phone before or through a headset like the HoloLens, I'm sure you understand the potential that it has. And so while we've not particularly used it that much, we certainly are being vigilant and playing with prototypes here and there. And there's some robust discussion within the company about what we should do with it. But we see the potential for augmented reality, and it's definitely going to be huge. And for those maybe who are a little bit unfamiliar with augmented reality and its difference to virtual reality, augmented reality is typically where you still have a decent view of the real world, but you just have digital objects augmented into that view that you have of the real world. And the ideal is that these digital objects, will feel natural in the world. And I think that's where everybody's trying to go with it. But those are hard challenges. And while progress is being made, I don't personally think it's there yet. But so what do these enable besides the things we've spoken about for the last half hour or so? Well, I think there are two other interesting areas, and they are remote meetings and training. So when it comes to training, it is incredible how much easier it is to remember how to do something when you've actually done the actions using a VR headset and the controllers. We have built a training module for substation switching, for instance. That is a highly dangerous task. One wrong move in the real world is deadly, and so training is really important there. But there's a big difference between training out of a textbook and training in VR, where you're seeing the exact components that you're going to be working with. You get a feel for their size, where they are in a room, and in relation to the larger place that you're working in, and you do the actions. You press the buttons, you turn the handles. And so that really does build up unprecedented levels of memory in a trainee's head. And there are numerous studies out there that show the efficacy of virtual reality training. And so that's an area that we're really interested in, and it plays into that project pipeline. When you have these models available, you may as well eke out extra value from them down the line. It's not just useful anymore at the design phase to generate drawings. It's useful in all these other ways. And then the other one that I think is really interesting is for remote meetings. We've all had to get used to remote meetings since the beginning of the year, and I think that mixed reality really offers some really, really fascinating opportunities for remote meetings. When we each have an avatar of our own, and we can move naturally in a space, and we can feel like we're with other people, as opposed to these really awkward interactions that we have through Zoom and Teams. It can just be so much more natural, and we can be in interesting environments. We can be in the actual design, or we can be in a boardroom in the clouds, or wherever we want to be. So it doesn't only cut down on the need for travel, which I think is important. Everybody's looking to cut down on that and save where they can, but it can also just mean like really more effective meetings. That's what I believe, and I think we'll see a lot more of it in the near future. So that's it from me. I really do appreciate you taking the time to listen to me. I hope I managed to impart some useful, interesting information. Thanks for joining in the conference. I hope you enjoy the rest of it. Stay well.